Guys, Mr. Gucci here along with his cat Newt, and we are going to give you a little video for your Independent Work Wednesday. Okay, so let's get started on that. Here we go. All right, this is going to be short. I'm going to go through the notes briefly, and then I'm going to get you started on your worksheet. Once again, here's Newt. Oof, what a cutie. What a cutie. What a cutie. All right, so here we go, guys. We're talking about Lewis dot structures today. All right, again, short notes. Here we go. So, molecules are groups of covalently bonded nonmetals, all right? Because only nonmetals covalently bond. So, molecules can include things like solids, like sugar, diamond, fat, plastic, liquids, like water, oil, or kerosene, are also molecules, as well as gases, carbon monoxide, carbon dioxide, and so forth, okay? These are molecules. Any substance that is made out of covalently bonded nonmetals is a molecule. Now, there are different ways to draw molecules, but all of them are based around the same idea in that you use letters to represent the different atoms that are involved, and you use lines to represent the bonds that connect them. For example, all three of these images here all represent the exact same molecule, glucose. All right, they're just represented in slightly different ways. The way that we are going to represent molecules in this class is with structural formulas. It is an illustration that shows how atoms of a molecule are bonded. Again, a symbol, one symbol for each atom involved, and we just use the elemental symbol from the periodic table. So, for example, we'd use an O to represent oxygen, a C to represent carbon, and so forth, all right? And we use a line to represent a bond between those atoms, all right? One bond made up of a pair of shared electrons, okay? Now, something to keep in mind in the future, each bond that occurs is a pair of electrons that are being shared between two nonmetal atoms. All right, so again, here's an example. Here's dicarbon hexahydride, okay? This is its chemical formula, and its structural formula is this. You'll see how there's two carbons here to represent the two carbons, and there are 6 hydrogens, and this is how they are connected. The carbons are connected to each other, and each carbon is then connected to 3 hydrogens. That is the structural formula of dicarbon hexahydride. All right, here's dicarbon tetrahydride, C2H4, and here's how they are connected. Okay, again, the carbons are connected to each other twice, and each carbon is connected then to 2 other hydrogens. And here's dicarbon dihydride, C2H2, all right, where the carbons are connected together 3 times, and then each carbon is also connected to a hydrogen. Okay, so these are the structural formulas that we are going to be figuring out, and we are going to be drawing on Thursday and Friday. Now, in order to draw these molecules, these structural formulas, we are going to use something called the Lewis dot diagrams. Okay, Lewis dot diagrams is a system to figure out how atoms bond together to form molecules so that we can draw. All right, and we do it by writing the symbol for an atom, and then we place dots around the outside of that symbol to represent how many valence electrons that atom has. And then we're going to play a game on Thursday and Friday where we connect these dots in a special way in order to build a molecule. Right? It's going to be like a fun connect the dot type game that we create. Okay? So, again, here are some examples of some Lewis dot structures for different elements. Okay? So here's the Lewis dot structure for carbon, for nitrogen, and for oxygen. Okay? Now, today we're going to work on drawing these Lewis dot structures. Okay? Because in order to make the big molecular diagram, we have to be able to draw the individual Lewis dot structures for the individual atoms that are involved. Okay, now the process for this is real simple. I'm going to walk through it, then I'm going to do some examples for you. Okay, so here's how we draw the Lewis dot structure for an atom. Okay, first, when I tell you to draw the Lewis dot structure of an atom, your first step should be to identify the number of valence electrons that this atom has. For example, oxygen has 6 valence electrons. You can tell this by looking at the periodic table. Next step, draw the symbol for the element. Simple enough. Pull the symbol right off the periodic table. Step 3, place dots around that element symbol, 1 dot for each of its valence electrons, and you have to go in order. All right, start at the top, do the first one on the top, then the second one on the right, then the bottom, then the left, then the top, then the right, then the bottom, then the left. Go clockwise around the atom, placing these dots, okay, until you run out. You're never going to place more than 8 of them. So at most, you're going to go top, right, bottom, left, top, right, bottom, left, and then you've placed them all. Stop when you are out of valence electrons, okay? So here's how this is going to help us out, right? So here's again, the Lewis dot structure for oxygen. These electrons here that have been doubled up as we go around, these guys don't bond. They will not form any bonds. We call these guys lone pairs because they're pairs of electrons that keep to themselves. They don't bond. These single electrons that we're left with as we draw the electrons around the symbol, these are called unpaired electrons. These are the electrons that will form bonds. However many of these unpaired electrons you have around the central atom, that is how many bonds that particular atom will form. And that's going to be very important for the game we're going to play on Thursday and Friday, where we connect these dots and build up these molecules. Okay, so let's take a look here. Let's take a look. All right, so I'm going to do some sample problems for you now. Okay. Oh, before I do, just double check real quick, right? Again, you are going to want to do these dots in order around the outside. Top, right, bottom, left. Top, right, bottom, left. And when you put 2 of them on the same side, you're going to put them close together, okay? You don't want to end up like just working your way slowly around the atom. You don't want to go top, top, right, right, bottom, bottom. You want to go in order, okay? There's the good way to do it, and then there's the bad way to do it. Do it the good way. Let me show you an example of this, okay? So here we do it. I'm going to go to the Google Classroom, okay? I'm going to open up, nope, not that one. Okay, as a sample here, I've pulled up the Period 1 Google Classroom. Okay, I'm going to go to the classwork section here. And here we are, the Independent Work Wednesday activity, Intro to Lewis dot structures. I'm going to open up your homework. Or rather, I'm going to open up a sample. Okay, so here's how this goes. You are going to have to do the Lewis dot structure for 11 different elements. Now, again, the process is simple. First step, you are going to look the element up on the periodic table to figure out how many valence electrons it has. And if we go look at the notes that I gave you this handy-dandy chart here that tells you how many valence electrons it has. Okay, so let me just blow this up a little bit so it's easier to see. That's less easy to see. I'll just go back to 100%. Okay, cool. All right, so here we go. Now, can I make this smaller? I cannot. I'll be down here. Hi, everyone. Okay, so here we go. All right, let's do this Intro to Lewis dot structure worksheet. Now, I did this in a Jamboard because you're going to be doing a lot of drawing, and you can draw on a Jamboard using your mouse. All you have to do is click the pen symbol and then draw anywhere on the Jamboard, and it draws it, okay? If you have a touchscreen laptop from the school, that works great. You can use your mouse. That's also great. If none of this works for you, then I recommend that you, write it on a separate sheet of paper and then just take a picture and attach it. Okay, so here we go. Let's do some of these Lewis dot structures. Now, what is the Lewis dot structure for silicon? Okay, let me find silicon on the periodic table. All right, silicon is here. Silicon is right here. It is Si. It is in this column that has 4 valence electrons. Okay, so the Lewis dot structure for silicon, I'm going to take the pen, go black pen. All right, it has 4 valence electrons. So here I go. I'm going to draw silicon. Okay, so symbol is Si, and it has 4 valence electrons. So I'm going to go top, right, bottom, left. Okay? Now, the number of single electrons around that central atom, that tells us how many covalent bonds are going to form. So this atom is going to form 1, 2, 3, 4 covalent bonds. All right, it forms 4 covalent bonds. Okay, let's try another one. Arsenic. So first step, find arsenic on the periodic table and figure out how many valence electrons it has. So here I go. Arsenic is As. Okay, As is arsenic. It has 5 valence electrons. So I'm going to write that in. Okay, so arsenic is As. Okay, now I'm going to go. Start on the top. Top, right, bottom, left, top, just like that. Okay, in that order. Let me clean it up a little bit. Bring this guy closer to the rest. Okay, there we go. That's the Lewis dot structure for arsenic. Now, how many potential covalent bonds can this form? Every single electron around the central atom can form a bond. So this guy can form up to 1, 2, 3. It can form up to 3 covalent bonds. Okay, let's try astatine. All right, this is one you might not have heard of before. Okay, astatine is At right here. Okay, it is in this group right here that has 7 valence electrons. So astatine has 7 valence electrons. Okay, symbol is A. T. Now I'm going to draw in these electrons around the outside. Okay, so 1, 2, 3, 4, 5, 6, 7. There we go. That is the Lewis dot structure for astatine. Now, how many potential covalent bonds is it going to make? Just look for how many unpaired single electrons there are around that central atom. In this case, there's only 1. Okay, so this guy is only going to form 1 covalent bond. All right, let's take a look at krypton. Okay, krypton. Krypton is Kr. It's in this column with 8 valence electrons. So here we go. It's 8 electrons. So Kr, krypton. Here we go. 1. And you have to go in this order, guys. Just how you got to do it. 2, 3, 4, 5, 6, 7, 8. Like that. Okay? So how many potential covalent bonds can krypton form? Well, let's see here. There are no unpaired electrons around this central atom. So this guy is going to form 0 covalent bonds. And that jives with what we know about the noble gases. They don't form any covalent bonds. Let's do the last one. The last one is tellurium. All right, Te, tellurium. Okay, it is in this column right here with oxygen, sulfur, and selenium. All these atoms have 6 valence electrons. Okay, so here we go. And again, you could be doing this with your mouse. If you don't like drawing this on your computer screen with a mouse, if you don't have a touch screen, then by all means, just do this on a separate sheet of paper, take a picture, and submit it to me. Just make sure you include all the information that is asked for here, right? So tellurium has 6 valence electrons. 6 valence electrons. So the symbol for tellurium, I think, was Te. I don't encounter it that often yet. Te. Te. All right, so here we go. 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay, so very much the same electron, the same Lewis dot format as oxygen. All right, how many bonds is this going to form? Well, again, look for how many unpaired electrons there are. Here's an unpaired electron. Here's an unpaired electron. So this atom can form 2, at most 2 covalent bonds. Okay, guys, so this is how you do the homework. Okay, I have posted attached to the homework some potential answers for you to help you check yourself, right? If you go to the next slide over, here's a few of the sample ones here to help you out. Okay, but I think you can do it on your own after watching this. Okay, now where we're going to go from here? From here, starting on Thursday and Friday, you're going to come in being like, okay, I can draw these Lewis dots, Mr. Gucci. They're pretty easy. You just take the symbol and then you do the dots around the outside. You know, up, right, bottom, left, bing, bang, boom. Next game we're going to play is we are going to build molecules by putting these symbols together on a page and connecting the dots. Every unpaired electron gets connected to another unpaired electron, and this is how we can build up the models of different molecules. All right, guys, so I wish you luck. Email if you have any questions. Good luck.